Lecture 3-2, Complex Number Math and Calculators. Please read Appendix B of your textbook for more details on this topic. The learning objectives include performing complex number addition, subtraction, multiplication, and addition using your calculator, and also performing complex number math to solve simultaneous equations in your calculator. You should be using a TI calculator to follow this lecture, so if you have an HP or Sharp or Casio or any other kind of calculator, please refer to your user manual. First, for TI calculators 89 and above, you can use csolve or csimult with your calculator in polar mode, angle, degrees, and radians in order to solve simultaneous systems of equations. If you have anything before an 89, you're going to have to do a special technique, which I will teach you here. So for the TI-89, what you're going to do is you're going to do csolve, and you just type in the equation exactly like it looks on the paper, and then you put in a comma, and in the parens, the braces, you put the variables you want to solve for. csimult is very similar, except you put in a matrix instead of the equations. So please refer to your manual for more details on that. For TI calculators before TI-89, we have to do a special trick with the matrix that's based upon linear algebra. Although I haven't explored exactly why it works, it's definitely based upon reduced row echelon form. And it involves taking each complex number, such as a plus jb, and writing it as a 2 by 2, which is a negative b, ba. So it looks a lot like the adjoint or cofactor matrix. And you have to make sure all the values in the equation are in rectangular form. So for example, to solve this problem, we are going to have the following matrix, which is a 4 by 6 matrix, where 1 plus 1 plus 7.32j is 2 angle 30 times x. Then you're going to have plus 2 plus 6i times y. So that makes up the second two columns. And that is going to equal 10 plus j3. That's going to equal 0 plus j3. And that makes up the last two columns. So those first two rows are for the first equation, and the second two rows are for the second equation. So for the second equation, we're going to have 1 plus 0j times x plus 1.879, negative 1.879 minus j 0.684 for y, and then that's going to equal 0 for a real number plus j. And so we basically convert that equation into this 4 by 6 matrix that we then solve by putting in second matrix math, reduced row echelon form to get the solution. So the result in your calculator is 1000.511 minus 0.948, 0100.948.511, 0010.231.111, and 0001 negative 0.111.231. So when we interpret that, we get that x is equal to 0.511 plus j 0.948, and y is equal to 0.231 minus j 0.111. Let's try another example. Use your calculator to solve the following system of equations. 1 plus j2i1 plus 3 minus j5i1 minus i2 equals 33.8. 2 times i2 plus 0.75vx plus 3 minus j5 times i2 minus i1 equals 0. And vx equals negative j5 times i1 minus i2. The first thing we need to do is rearrange these equations so that we collect like variables. So equation 1 would become 4 minus j3 i1 plus negative 3 plus j5 i2. And it's going to have 0 vx, and that equals 33.8. Equation 2 is going to have negative 3 minus j5 I1 plus 5 minus j5 I2 plus 1.5 Vx, and that equals 0. And the third equation is going to have negative J5 I1 plus J5 I2 minus 1 Vx equals 0. And from this, we are going to now build our matrix. And recall that if you have an 89 or Inspire, you're doing csolve or csimult. And it's going to be a 6 by 8 matrix. So the matrix is going to be separated in the rows by the 3 equations and separated in the columns by the variables. So we're going to mark off 2 rows for each equation. And we're going to also mark off 2 columns for each variable. So 2 for I1, 2 for I2, 2 for Vx, and 2 for the constant on the right side of the equal sign. And so then we are going to just put the values first. So that first column would be 4, negative 3. The second column would be negative 3 plus 5. And the last 2 rows in that first column would be 0, negative 5. And then remember, for the second column, you are going to put negative 3, 5, 5, negative 5, and 0, 5. Okay, that's for I2. Then for Vx, you're going to have 0, 0, 1.50, and negative 1, 0. Then for our constants, you're going to have 33.80, 0, 0, 0, 0. Now we have to go back and do what I'm calling the adjoint, which means that the first element in that column is now the negative of the 3 and the 4. Then the negative of the 5 and the negative 3. Remember, you only flip the sign on the second one, and then 5, 0. Then for the fourth column, we're going to have negative 5, negative 3, 5, 5, and negative 5, 0. Sixth column is going to be 0, 0, 0, 1.5, and 0, negative 1. And the last column is going to be 0, 33.8, 0, 0, 0, 0. So then when we put this in our calculator and do reduced row echelon form, we get that I1 is 29 plus J2 amps, or 29 with an angle of 3.9 degrees. I2 is 19.4 plus J6 amps, which equals 20 with an angle of 17 degrees. And Vx is equal to negative 20 minus J, 48 volts, which equals 52 with an angle of negative 113 degrees in volts. This concludes today's lecture on using our calculator for complex number math.